And hence, let us prove this important result in circles. An angle subtended at the center of the circle by any arc, let's say BC, is twice the angle by the same arc on the circumference. Right? A is any point on the circumference, on the other part of the circumference. So BAC is any other angle. BOC is twice BAC. Right? Now this A can be here, 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 anyway. Right? This is what we have to prove. This is Euclid's 20th proposition is book number 3 of elements. Right? This is a very nice theorem, very important theorem. Let us prove. Right? This A can be here, can be here, can be here. BOC can be acute angle, can be 180 degrees or can be more than 180 degrees also. Right? At the same time, the AB can touch OC, AB need not touch OC. Right? Let's prove. Everywhere, the proof is more or less the same. Let us start with the original one. Right? Let us take this triangle AOB. AOB. Here, BO and AO are radii. Right? AO is equal to BO because both are radii only. Right. So in this triangle OAB, this angle and this angle, right, they will be same. Right. For example, AOB, ABO, this side is equal to this side, so this angle will be equal to this angle. Right. Let's call both of them as X. So this is X, this is also X. Now let us extend this AO, let us extend to D. This becomes exterior angle. These two are opposite interior angles. So this is exterior angle and these two are opposite interior angles. Right. Exterior angle is sum of interior opposite two angles. Right. We know that. So this becomes 2x. Right. BOD becomes 2x. Similarly, in this triangle, same OAC. In this triangle OAC, OA and OC are radii. What does that mean? This angle OAC is equal to OCA because these are angles opposite equal sides. So this will become y. Let us assume if this becomes y, this is also y. And what does and again this angle DOC is exterior opposite angle. If AO this is O and this is D, this is C. This angle is equal to this angle. This angle is equal to sum of this angle and this angle. If both are y's, this becomes 2y. This is 2y. Right. So angle BOC is equal to 2x plus 2y is equal to 2 into x plus y. X plus y is what? BAC. This angle is x plus y, right? Is equal to 2 into angle BAC. This is what we wanted, right? Which we have proved. Now let's go to the other parts. Let's say what if AB is touching OC? Then also no problem. Then also let's continue with the same proof. Right. Again OB and OA, these are radii. That's why this angle and this is x, this is x, this is x. Right. Now when OBA triangle, this let's extend again OD. Right. AOD, let's extend. So this is exterior opposite angle, which is equal to sum of interior opposite angles, right? So this is 2x. Right. Now let's take again AOC. Right. This is AOC. OA is equal to OC. OC is equal to OA. So that means this angle is equal to this angle. Let's say this is P and this is also P. Okay. Now let's extend this angle. AOB. Then this is again extended opposite angles. This becomes 2p. Right, sum of this plus this. Right, this is D. Right, now this entire part is 2p. Right, this entire part is 2p. This entire part. Right, and okay, and what is BOC? DOC is 2p. DOC is 2p. BOC is equal to 2p minus DOB is 2x. Right? 2p minus 2x. Right? Which is equal to 2 into p minus x. Right? 2p minus 2x is what? 2 into p minus x. And we already decided AC is p. AC is p. OAC is p. And OAB is x. So what is BAC? OAB is x. Right. This part is x. The total part is this total is p. Sorry. This total is p. Right. So then what is BAC? BAC is p minus x. Right. The total part minus this x part. Right. P minus x. 2p minus x is BAC. What does that mean? 2 into BAC, which is what we wanted to prove. BOC is equal to 2 into BAC again, right? So this is also proved. Now, this part is again more or less same like the first one. The diagram is same. This is equal to this. So that means this is x. This is also x. And this is exterior opposite angle this part. So this becomes 2x. Similarly, this is x. This and this are same. So this is y. This is y. So, and this part is 2y. That means BOC is equal to 2 into x plus y, which is 2 into BAC. Right. So this is straightforward. Now this is also same. This and this are radii. So this is x. This is x. This part is exterior opposite angle. This part. So this is 2x. Similarly, this and this are same. This is y. This is also y. So again, DOC is exterior opposite angle. So this becomes 2y. 2 into x plus y. BOC is equal to BOC is again 2x plus 2y. Right, which is equal to 2 into angle BAC. Right. So all are same. We are using the same rule. Wherever this point is lying, wherever the point is lying, here, and wherever BC are, whether they are lesser than 90 degrees, whether they are 180 degrees or greater than 180 degrees. It doesn't matter. Angle at the center is double that of angle on the circumference by the same arc. Right, this is such a nice problem. Hope you understood this. Nice theorem. We use this theorem in multiple places. It is very good to get this conceptual clarity to tackle multiple exams. Thank you, guys.